All right, page 296, we're going to start with example 1. And what we're going to do is we're going to read the instructions, and then I'll go step by step. I'm going to list out the steps on how to figure out these patterns and put them into equations. So can someone read for me the instructions of example 1, the bold type, please? Nate.
Plot the points in the relation shown in the table. Then write an equation in functional notation for the equation.
Okay, does everyone see that top blue table at the top of that example? Does anyone know where they got those numbers from? Where in the world did they get those numbers from? Anyone know? Lucy. Okay, do you guys see the graph to the far right? Okay, that is a graph with points. I don't mind if the class waits for you. Those are the graphs. That's the graph with points that are now listed in that table. So what I want you to do is I want you to create that table, and it doesn't have to be immaculate, but it just has to have the data there. So go ahead and list out those. I think it's 5 points. Because this table is going to help us to see the pattern a little bit easier. And then next chapter, we're going to be able to see how the graph itself shows me the pattern very, very clearly. But I want to look at it through a table first. Okay. So I'm looking at this table, and I want to find a pattern. There are two sets of numbers up here. There are the x numbers, and there are the y numbers. Do you guys remember what the set of x coordinates are called? Domain. Do you guys remember that from last quiz?
Yes.
Okay. Do you guys see the set of y coordinates, which are called the range? Question?
Can I see the pattern?
How about this? Let me write the first step, and then I'll have you do it for me. All right. The first step in finding the equation from this pattern here is to find the differences. So what does differences refer to? What operation? Differences. Subtraction. So we're doing a lot of subtracting here. And do you remember that addition and subtraction are similar? So it's like you're doing addition in a sense as well. All right, find the differences. And I'm going to do it in two sections. I'm going to do it with the range and with the domain. I'm going to start off with the range. All right, Jack, looking at this bottom set of y coordinates, or the range, what's the difference between each number? 1. So from here to here, difference of 1. 1. And go ahead and draw this on your chart because this is going to help you. Now, how did I find that difference? I want to show it to you. With subtraction, so you can kind of see it, because this is an easy one, thankfully, to start off with. So the range, in order to find that out, I would do 2 minus 1. What's 2 minus 1? 1. What's 3 minus 2? And then what's 4 minus 3? Okay, so you see how we're just doing that subtraction to find the difference. You guys see that? Okay. So the differences in the ranges, or the range values, are 1. Okay, positive 1. Okay, somebody else tell me, what's the difference, and this is a tough one, with the domain values, with the domain, the x coordinates. And there are two ways to say it. So two ways to say it, but one's actually correct, one's almost correct. Jenna? Okay, actually you said it well. You subtract 4 or you add negative 4 to get to the next one. And I will accept that because it's correct. And you're like, wait, do you add negative 4 or do you add positive 4? Well, look at it here. What did you add to get from negative 4 to negative 8? You added negative 4. Or you would say, what difference did I get when I did negative 8 minus negative 4? I'm going to write that down because that's domain now. We're on B. domain, and we did -8 minus -4. All right, ready? -8 minus -4. What's that? -4. And then the other set, or the other part of the pattern, would be -12 minus -8. So what's -12 minus -8? -4. Okay, do you guys see that the difference in all of these in the domain and range are the same? You see here, these are all -4, all +1. You guys okay with that? Okay, that's your first step. Find those differences. Any questions on that? Okay, second step, after the first step, is actually not that bad. We're going to set a ratio. What's a ratio? Yeah, what's a ratio? Comparing two numbers, okay? The two numbers that we're going to compare are going to be the range, and this is something important, range differences over the domain differences. Did you have a question?
Yeah, I was just I didn't get range.
Okay, so range differences over domain differences for the ratio. So maybe some of you are thinking at this point, which is totally okay, what are we doing? What are we trying to find? Well, what's the title of this chapter? Writing equations from the pattern. All right, everyone okay with the pattern? Can you see a pattern? But we still haven't come up with an equation, have we? That's what we're working toward right now. But I do see that there is a ratio, and it's between the range differences and the domain differences. What is the range difference? What's the range difference every time you move from one domain or one range value to the next? Jack? 1. That's our top number. What's the domain difference as you change from one domain value to the next? -4. -4. All right? That's our ratio. We have it. It's 1 over -4. How else can you write that, by the way? Anyone? Yes? -1/4 is the same thing as 1 over -4. Okay? So far, so good? We got a ratio. You're like, okay, that sounds really cool. What's the point of the ratio? Step 3. You begin, and I guess I should say writing equation, but begin equation and test coordinates. Okay, here's a very important step. I'm going to begin my equation. What variables did I have in this equation, or in this table? What variables did I have?
Even number before.
What variables? I think I heard it. X and Y, right? So I have my equation. Y equals -1/4 X. Does that equation, not that specific one, but does that format look familiar to anyone?
Yes.
Okay. How in the world did I come up with it? Okay, let's look at each piece. How did I come up with this? It's the ratio up here. I got the ratio, and I got it right here. Now, how do I know that X goes here and Y goes there? That's a tough question. Oh, right? We solve for Y. We solve for the dependent variable. And where's the dependent variable listed on the table? Is it the first row or the second row? Second row. So you're solving for that variable in the second row. Okay. Is this really my equation? I have no idea right now. I don't. You know how I'm going to figure it out? I need to do what? Test coordinates. Can anyone give me one coordinate from that table? One ordered pair from that table. Jenna? Sorry, ordered pair.
Oh, ordered pair.
Yep. Say that again.
-4.
Was that from that table?
Yes.
Okay. It's going to be -4, 1. Thank you very much. Sorry. I don't have it in front of me. -4, 1. Give me another one. Somebody else. Just give me another ordered pair. Abby? Any ordered pair from there. It doesn't matter. -8, 2. Okay. If this equation describes that pattern, shouldn't both of these values fit into this equation? Okay, so I'm going to check it out. That's what we're doing. This is a testing part. All right, x equals -4, y equals 1. So I'm going to replace y with 1, and then x with -4. All right, so all I did is substitute. And then I had to find out, is that a true equation? So we got to make sure. What's a negative times a negative? So that's positive. What happens to these 4s? Cancel out, become 1 over 1. What's 1 times 1? So is 1 equal to 1? Do you remember doing this? Do you remember putting an ordered pair, bless you? Do you remember putting an ordered pair into an equation and seeing if it works? Jackson? Okay, you do remember. All right, let's do another one here to test out the second coordinate. Does -8 and 2 fit? So 2 is for y and -1. Wow, I keep wanting to do that. -1/4 and x is -8. Does that work? What's a negative times a negative? What happens to this 4 and 8? So what's this right here? Does 2 equal 2? He meant to say yes. Okay, 2 equals 2? Okay, does this equation, the one that we came up with, does this describe that pattern? The answer is yes. So, last step here. It's my favorite step. The other ones are good, but this is my favorite. Step 4, write the equation. I can make it 5, 6, or 7. Which one do you want?
8.
How about 4? We'll stick with 4. That's it. That's your equation. You're done. The reason this is a step is because sometimes you get to this testing point and you realize this equation that you came up with is wrong. And then you're going to figure out how to fix it. Okay, so you see how we got that pattern? Not very hard. Just a lot of steps. Let's look at example 2, and then I'll have you do one on your own. So I need you guys to please pay attention with me because you're going to have to do it on your own anyway. Example number 2 is really tough. You know why it's really tough? Because in the last example, they gave you a really nice, clean, easy to see pattern. On this example, the pattern's not so clean. It's not so easy to see. So can someone read the instructions in example 2? Yes, ma'am.
Write any equation in function and partial notation with the relation graph at the right.
Okay, so they gave us a relation, and then how many points are on that graph to the right? How many points? 6 points. So I'm going to have six columns. And do I have X and Y on this one? No, I have what? K and M. What do you think K stands? Now, remember how I told you about alphabetically? Normally we list them out alphabetically. That's not always the case. But once you look at it here, what's X going to be? K. What's Y going to be? M. So we already know that. We're good with that. And then go ahead and list those parts. You got 1, 2, 4, 5, 6, 9. And then 8, 6, 2, 0, -2, -8. All right, so they got that from that graph. Do you think you guys can come up with those ordered pairs from the graph? I think you can. You actually showed it on that quiz, which is good. All right, step 1, what do we have to do here? Find the, there we go, find the differences. Which, yes, includes subtracting. Find the differences. I'm telling you, this one's going to be harder. We're going to look at it first with the range. Deal with the range first.
Do we have to write all this out for each problem?
You don't have to. All right, what are the differences with the range? So what's the difference right here? So what's 6 minus 8? Negative 2. 6 minus 8 is negative 2. What's 2 minus 6? Uh-oh, negative 4. Okay. What's 0 minus 2? Negative 2. What's negative 2 minus 0? I know that sounds tough, but it's actually very easy. Negative 2. So negative 2 minus 0 is still negative 2. And then what's negative 8 minus negative 2? Okay, good. Oh, wow. You guys are doing well. Negative 6. Good. Oh, my. That is not very nice. Is that a pattern?
Yeah.
Is this a pattern? 2, 4, 2, 2, 6. It is? Not to me. I don't see the pattern. You guys see it? What's the pattern? Explain to me. Go ahead.
So,
What would be the next term? How about that? That'll show me you explain it.
-2, and then -2, and then -8.
Really?
Yeah.
Interesting. Anyone else want to give me some next terms in the sequence? Negative 2?
Well, technically, you could just like add x and y values, so it would be -2, -2, -2, -2, -2.
You want to keep going? Okay. There's a pattern here, but it's not clear from the table. The table actually does not show me a specific pattern. Okay? So range differences, I have all of these. Okay? That's not nice. Let's look at the domain differences. Maybe that'll be nicer. All right, what are the domain differences? So what's 2 minus 1? 1. Oh, that's nice. Uh-oh. What's 4 minus 2? 2. What's 5 minus 4? What's 6 minus 5? What's 9 minus 6? 1, 2, 1, 1, 3. Oh, I could... No, I can't. Can't see the pattern. This is confusing. This is confusing.
You just need to change the x value and change the y value to make it all.
So just change it all.
Well, just add them.
Just add them.
Just add them
Combine them. I'm upset here actually because I don't see a nice pattern. I like patterns. Ma'am?
for the each value.
You do kind of division. How many times is 1 minus 2? Or like, kind of, you cut each of them in half, basically.
Okay, I think you might be getting on to... Claire gave me an interesting thought. I'm going to do this. Hey, listen up. If I had just this right here, so just, and I'll use a little marker, and I'm going to highlight very gently here. If I had just this, what would be my ratio for the range differences? Close. So set the ratio. I think I heard it. I'm not sure if I heard it completely correct. Negative 2 over 1. If I just use those, it would be negative 2 over 1. So I'm going to put this, negative 2 over 1. That would be one of them. If I had that pattern going. What would it be if I was using these two numbers? What would it be? Negative 4 over 2, right? Okay, thanks. And what would it be? And actually, do you guys see that these two are the same? Okay, what would it be if I was using this one right here? Because that's different. Negative 6 over 3, right? Huh. Whoa. Equal. Yeah. Oh, okay, got it. Nate, what do you see? wrote it wrong. Thank you. I'm sorry. I think I like rations. Or, yeah. Yeah, I guess. So, Jack, you look very eager. What's up with these right here? You mean they're all the same?
Yes. If you multiply negative 2 over 1 by
2 over 2?
yeah,
Or 3 over 3?
Yeah.
Good. Hey guys, you remember what a ratio is? It's a comparison of two numbers. What do we do with ratios that can be reduced? We reduce them. So what does this become? What does this become? So you know what the ratio is? Negative 2 over 1. That's the ratio. It is negative 2 over 1. All of them point to negative 2 over 1. Now, I'm going to go with number 3. Does anyone know what my equation is so far? Now, don't use y and x, because y and x are not in that problem. But can someone use k and m? M equals. Super close. M equals. Yeah, negative 2 over 1. How can you rewrite that? Negative 2? K, right? And, yeah, negative 2k. So I'm going to write this step down. Test coordinates. All right, listen up. Listen up. I have an equation that I think is right. It looks pretty good. It looks good, but what do I have to do? Test coordinates. I want somebody to give me two coordinates there. One set of ordered pair, and then someone else give me another set. Go ahead.
8, 1.
Is that one of them?
Yeah.
8, 1. Okay, give me another one, somebody else. Yeah, and so the x is the first number, the y. Oh, you're right. Yeah. Thank you, Claire. Yeah, it's 1, 8. Because the x is the top number and the y is the bottom number. Is that on your graph? It's the same thing. It was negative 4, 1. No, that's this part, but our coordinates are like that. That's okay. Can anyone give me a second coordinate? Turner, let's pick one.
Negative 8,
9,
negative
9, negative 8. Okay, we're going to use both of those. All right, do they work? Let's see here. So remember, this is K and M, right? K and M. So you got to put them in the right spots. So 8 equals negative 2 times 1. Oh, does that work out? Okay, let's see. I'm just going to write this. No, it doesn't work out. It's a fail. Okay, but maybe that was a fluke. Let's try the next one. Down here, is it 9, negative 8? Okay, good. Negative 8 equals negative 2 times 9. So what's negative 2 times 9? Negative 18. Oh, no. That is not it. Oh, my goodness. What's happening here? Distress mode here. Okay. Oh, sorry. This is not an x. It should be. Oh, it is an x, but it's not a variable. I don't want to throw myself off. That's not correct. All right. Do you see something, Jack? What do you see? And I'll make this bigger so it doesn't look like a variable. It's a big X. Like, no, it doesn't work. Okay, what do you see?
Well, you said ratios when we were talking about that you have to simplify them. And those are not simplified.
You mean this right here?
Yeah. So if you simplify them, it would be 4 and a negative 1 and a negative 1. And then if you simplify that one, then it would be negative.
Actually, Jack, so that's great thinking because you're looking at these saying, can you make them simpler? Maybe they relate better. It won't work that way, but that's actually a good thought. You're getting close. There's something about those numbers. Look at it here. You know when I multiply these out, what did I want this number to be? I wanted it to be 8, right? How far off am I from 8? I'm 10 off, right? I wanted this number to be what? Negative 8, and I got negative 18. How far am I off? I'm off 10 again. That's kind of strange. A pattern within a pattern. Let's do one more point. Give me another point. Give me another point here. Here's. Sorry, from the list here. That's okay. Maggie. 6, negative 2. Fine. 6, negative 2. All right, let's see here. Third time's the charm. Negative 2 equals negative 2 times 6. Okay, ready? What's negative 2 times 6? Oh my goodness, you gotta be kidding me. Oh, how far are they off? How far are these off? 10. You know they're always off by 10? No matter what I do. Ready? 5. Is that on there? 5, 0? Fine. 5, 0.
Not the first one, not 1, 8.
Okay, ready? 0 equals negative 2 times 5. 0 equals... Oh, come on, Jenna. Are you just playing a joke? You got my hope up. My hope. It's off by 10 again. You know what? Bingo. There's a pattern within the pattern. Here it is. Remember how I thought my equation was, make sure m equals negative 2k. Remember that? It's not that. That's only part of it. The second part will be either plus 10 or it will be m equals negative 2k minus 10. It's one of those. Because isn't the difference between what I want and what I'm getting 10? Okay, which one is the correct equation? Only one of them can be.
The second one.
So I heard second one. Anyone for the first? I like positive. I like negative. It's got to be one of them, and you can test it out. All right. What do I have to do to negative 10 to make it 0? I have to add 10. All right, so keep that in mind. What do I have to do to negative 12 to get to negative 2? So far, add 10, add 10. What do I have to do from negative 18 to negative 8? Anyone see the pattern?
Yeah, minus 10.
Oh, my.
But what about the first one that we did, the 1, 8?
Okay, let's test it out here. 1, 8, right? So I think this is my fourth step. Sorry. 1, 8. So 1, 8. Let's see. 8 equals negative 2 times 1 plus 10. Does that work? It works. We got it. This is my equation. A pattern within a pattern. Isn't that nice? It doesn't work? Please tell me if it doesn't work. You guys doing okay over there?
No, that's her.
Yeah, try not to distract. Remember, guys, because this is tough. Yes, ma'am? Hold on.
How does that work? 'Cause
What's negative 2 times 1? Negative 2 plus 10, 8. Negative 2 plus 10 is 8. That's okay.
It was 2K10, but now it's your 1 plus 10.
All right, this is what I want you to do since you guys are so ready for this, based on your talking. I want you to do on page 299, I want you to look at number 11. This is the first problem in your homework that I'm going to give you. And all you have to do, and actually that's why I had to change my plans here, I had to find those two missing numbers in that table. And you're like, oh, it's so easy. Number 11.
That's it?
Nope.
Oh.
So this is what I need you to do.
Yes.
Just so. That's okay. Go ahead and copy that table and put those numbers where they belong, because you're going to need that table. So put the numbers where they belong. I hope you can find that pattern. For number 11, you're trying to find that pattern. And then you're going to copy that table because you're going to do this for your homework as well, so I need you to pay attention. And you don't have many problems, but I do want you to do what we're going to do now on these problems. Thankfully, they give us f and f of x. F of x, what is that? It's y. Okay, so f of x is y. Don't get too scared. 1. Do they go 1, 2, 3, 4, 5?
Yeah.
All right. And then they give me 24, 36, 48, and 60. You got 48 and 60 in there? Good job. What I need you to do on this assignment is for number 11, fill in those spots. And then you have to give me what's the ratio range differences over domain differences. So you got to give me a ratio, and I'll try to spell it right this time. Ratio is something over something. So you're like, what do we put on the top? Well, what's the top value? The range differences. What's the difference between these two? 12. Here? 12. 12. 12. What's the differences here? What's the ratio? And I'll actually kind of bring it down lower. 12 over 1, which is also known as 12. That's part of your answer too. So fill in the blanks, give me the ratio. Your homework is 11 through 15, all. And 21. Yes, because I just gave it to you. Oh my. 11 through 15 and number 21. Page 299 and 300. Shh, don't keep saying that name. Yeah, don't say that either. That's a euphemism for that name.
What?